This is a continuation of another video. In that video, we found the regression equation in the following situation. A very large class has completed for the semester. The instructor summarized the data as follows. The average of the midterm scores was 65, the standard deviation was 20. The average of the final scores was 75, and the standard deviation was 15. The correlation coefficient was 0.6. The scatter diagram was football-shaped, and we want to answer the following. So in part A, we found the regression equation. Now for part B, what is the estimate? We want to estimate the percentage of students that got an A, which is better than 90 on the final exam. For this part, we just need the average and standard deviation of the final. The average of the final was 75. The standard deviation was 15. We are doing a normal approximation here. We want to figure out the percentage of students that did better than 90 on the final. That is, we are looking for the area shaded in light blue. To figure this out, we need to convert to standard units. To do that, we take the 90, subtract the average, and divide by the standard deviation. (90 minus 75 is 15. If we divide by 15, we get 1. So we're looking for the area under the normal curve to the right of 1. To figure that out, we find the area between minus 1 and 1. That is 68.27. We take 100 and subtract from that 68.27, and we divide by 2. The 68.27 comes from the normal curve table. So 100 minus 68.27 is 31.73. Divide by 2. That is 15.865. So our answer to part B is 15.865%. Moving on to part C. This problem is new. Of the students that got an 80 on the midterm exam, predict the number of students that got an A on the final exam. I'm going to change that number to percent. To solve this problem, we need all of the information. So in X, the average was 65, the standard deviation was 20. Let's do Y in a different color. The average was 75 and the standard deviation was 50. The correlation's coefficient was 0.6. Now we can use the regression equation here. So let's recall that the regression equation was Y equals 0.45 times X plus, and we need the intercept, so let's go back, is 45.75. So that's the regression equation calculated in part A. Now first, let's ask ourselves what this question is asking. It's actually a two-dimensional equation, two-dimensional question we're asking with regards to two variables. We're saying of the students that got an 80, let me check. Of the students that got an 80 on the midterm, we want to know what percentage of students did better than 90 on the final. This means we're actually looking within a vertical strip rather than all of the data. We're saying which students, what percentage of the overall population is in this region right here. In order to figure that out, we are going to use normal approximation. We can do that because this scatter diagram is football shaped. So we need to figure out what is called the new average, the average of all the y values in that vertical strip. What we're going to do is we're going to plug in x equals 80. So given that the midterm score was 80, to the regression equation. So if we plug that in, 0.45 times 80 equals 36 plus 45.75 equals 81.75. So what we're claiming here is that the average of the y-coordinates within the vertical strip is 81.75. But the standard deviation, the spread of the data, is also different than what it is overall. The spread within that vertical strip is the root mean squared error. We have a formula for that. That's the square root of 1 minus r squared times the standard deviation of y. So our new standard deviation is the square root of 1 minus 0.6 squared. 0.6 squared because r is 0.6, and we multiply that by the standard deviation of y. The standard deviation of y was 15. Now we calculate that. 0.6 squared is 0.36. One minus 0.36 is 0.64. I'm keeping track because we want to make sure this answer is correct. Take the square root, it's 0.8. Then we multiply that by 15 and we get 12. So our new average was 81.75 and our new standard deviation is 12. From this point forward, it's very similar to what we did in part B. We want to find the area under the normal curve to the right of 90. We need to convert 90 to standard units. So we do 90 minus the new average, 81.75, divided by the new standard deviation of 12. 90 minus 81.75 is 8.25, and we divide by 12 to get 0.6875. So we're going to take 100 minus whatever the area under the normal curve is between negative 0.6875 and 0.6875, and we're going to divide that by 2. So if you go to the normal curve table, we're looking for 0.6875. Well, none of the values here are 0.6875, so we go to the closest one. 0.7 is going to be the closest one, and that's an area of 51.61. So 100 minus 51.61 is 48.39, and we divide that by 2 to get 24.195%. That is less than the percentage we found in part, that is greater than the percentage we found in part B. That makes sense if you think about it logically. If you did well on the midterm, you were slightly more likely to do well on the final exam, and that's why the percentage is greater. Alright, I'll end the video here. If you have any questions, please ask on the discussion board.